All right, it is 5 minutes past the hour. The first session on the first day, we always have people coming in at various times, so we'll see how we go. Let me start the session. The intention of this presentation is just to introduce people to what Apan is and what Apan does, for those people that have not attended an Apan meeting before or haven't been involved with some of the Apan activities. My name is Dr. Markus Buchhorn. I'm the General Manager for Apan. I'm one of the few people paid to work in Apan. Almost everybody else is volunteer, except for our hardworking secretariat, who you'll see from time to time. I'm based in Canberra, Australia, so GMT plus 10 at the moment, for those of you in various other time zones. Apan was basically established in our region some time ago to provide a framework for a community to get together. At the time, I mean, even today, you keep in mind Asia Pacific region is more than half the world's population, well over half the world's population. And as a fraction of global activity related to research and development and education, it is increasingly a larger and larger proportion of those activities. We have significant growth and development occurring, and particularly in education and science and other areas. And we have a very strong focus, excuse me, in the Asia Pacific region around particular community needs. So particularly around things like food, agriculture, health, biosciences, ecology, environmental science, and so on. And we also have immense diversity in our region. And I'll explain a bit more about that in a moment. So Apan was formed in the region as a partnership with what we call the NRENs, and I'll explain NRENs in a moment, but the National Research and Education Networks. We have about 16, 17 economies or countries as primary members. They basically are the steering and governance body of Apan. But we have another 22 or more, 25 probably now, affiliates, associates, liaison, and industry partners. We've been around for a while. We were formed, depending on how you define formed, back in 1995, 96, 97. So formally, I think we kind of started in 97, so you'll hear references to being this our 25th year. We started as a very gentle MOU partnership between the member NRENs. And then in 2009, we became an incorporated company, headquartered legally in Hong Kong, even though we have very little presence in Hong Kong. We're very much an independent organization. We basically are run by the members. We have people who contribute small amounts of money, large amounts of money in network infrastructure, and who also participate in the governance of Apan. And where we started from was building connectivity within the region. And back in the 1990s, we were dealing with what today you'd call a home DSL connection at the very low quality, 1 to 2 megabits, but we did it within the region. And the reason we did this, I have to explain a bit more about what NRENs are. So the National Research and Education Networks are effectively an internet technology-based network that runs parallel to what we call the commercial internet. It's run by the sector, and it basically provides freeways, high-speed connectivity for research and education purposes. So we connect higher education institutions from universities right through to K-12 to sector. We support other kinds of research institutions as well, government agencies, research labs, the cultural institutions, sometimes called the GLAM sector, galleries, libraries, archives, and museums. Hospitals, medical institutes, bioscience institutes, and so on, and particularly research facilities. So things like major telescopes, microscopes, particle accelerators, compute capacity, storage facilities, and even nowadays, commercial cloud providers peer into the network as well to give researchers and educators high-speed access to their resources. So many of the NRENs now peer with Amazon, with Google, with Microsoft, with Apple, probably too. And what we've now done is we've now built connectivity within the region. This diagram started out back in the 1990s, and pretty much every economy there that had an internet link connected to the US. And it was ridiculous. When you consider, for example, Korea, Japan, that are less than 200 kilometers apart at their closest, they would both connect to each other via Seattle on the west coast of the US, because it was cheaper to do it that way. And it also leveraged the amount of activity going on in the US at the time around internet-based technologies. However, it meant the performance of applications across, between two sites anywhere in Asia was really badly impacted because of these huge high latency links that were basically shared with commodity internet providers. And so when Apan came along, it pushed the market to develop links within Asia much more. We started out with links that were, in some cases, down to 0.5 megabit. The first Australia-Japan link was 1.5 megabits, and I ran that link. And nowadays, we are dealing with multiples of 10 gigabit and 100 gigabit links across the region. And we're connected not just with North America, but also well connected now with Europe. And there's some emerging connectivity with the NREN partnerships in Africa as well. And through North America, we can also reach into Latin and South America. And there are many, many players involved, many funding bodies, many partners who contribute to all of these various links. And Apan provides that community framework to interconnect them all. The NRENs, like I said, are basically an internet-based technology, but the scale that they support is very, very different. Instead of having billions of users like the commercial internet, we have a much smaller community, but we have much bigger instruments, much bigger requirements. Data is one of the biggest drivers for most of research these days, and to some degree education as well. We now have instruments like the Large Hadron Collider in Europe that can generate petabytes of data per second. That is so much data that you can't really realistically move that in real time. So a lot of the compute capacity for that project is actually based at the research facility, and then researchers from around the world connect to that and replicate subsets of the data around the world. And that requires a whole bunch of things to work very, very seamlessly. The other thing we're seeing is that research is now very collaborative. It's very rare now for an individual researcher to make a major discovery. It is much more team-based, group-based, and it is not tied to a single institution. It's involved across many institutions. If you look at things like the bioscience research around the pandemic, the particle accelerator community, there are publications with over 1,000 authors involved, all partnering, all working together on these huge data sets and this huge compute capacity now. And so what we have is now we have these really high-speed networks with a fairly small user base, tens of thousands, hundreds of thousands, maybe 1 million users around the world. But we need that capacity to move these massive volumes of data around to compute, to analyze, to visualize, and so on. So when you have these NRENs built within a country, you then want to try and interconnect them, because researchers collaborate not just across institutions, they collaborate across borders. And so we have these, what we call the regional RNA network partnerships, of which Apan is an example. And what they try and do is they bring together all of the NRENs that have common interests, common requirements, and interconnect them in some fashion. Keep in mind that we can basically identify the demand and supply opportunities for networking connectivity. And if you've got 3 countries, then you can interconnect them with just 2 links. So you're saving money, you're making it more efficient. Now that, of course, requires somebody to have 2 links to each of the other countries. And so you have some countries stepping up with multiple links, acting like a hub, and then less wealthy countries or less developed countries can connect to one of these hub countries and so on. And so we need a framework for that discussion to occur. And as I said, research and education is very much internationally collaborative these days. There are many universities in many countries that have campuses now in other countries and share content and share teaching and research activities. The NRENs themselves have a really interesting set of challenges, and the way they're set up varies immensely. In some countries, they're basically an independent company that is owned by the universities. In other places, it's a partnership of universities, sometimes with a single lead university taking the lead. In many Asian economies, they're in fact government agencies. They're departments of ministries that provide network connectivity. And in some cases, you have multiples within a country, which gets a little confusing sometimes. They all have their own business model, their own funding model, and so on, and how they're set up varies a lot. And increasingly, what we're seeing is that they're providing not just connectivity, they're providing services above that. So they're not just providing connectivity amongst all the universities and schools and hospitals and whatever within a country, they also now support connectivity internationally and access to resources. In some cases, they even provide the resources. So some of the NRENs now run their own compute facilities or their own data storage facilities and services. They provide collaboration environments. Some of them provide access to commercial platforms like Zoom. Some of the NRENs also provide certificate and identity services. Many of them do training, project support, network design, engineering, and so on, even software development. And so each NREN has its own different approach to doing this. And so when we talk about APAN being a framework for the community to get together, it's the ability to try and harmonize these discussions and understand who's doing what, who's more advanced or doing new things in new areas, and it's going well or it's not going well, and so on. Now, keep in mind, the region we're dealing with has some of the biggest countries in the world and some of the smallest. So we have populations approaching, in fact, that's getting close to 1.5 billion in both China and India, to very, very small economies, in the Pacific Islands, South Asia, Central Asia, and so on. And the level of development varies immensely as well. We have very high socioeconomic standing countries, right through to very developing and emerging communities. But the need for connectivity is common to all of them. And then, we have this great cultural and political diversity as well. And one of the successes of APAN is that it's able to bring all of that together. Now, one of the things, APAN has a tagline of connecting people, cultures, research, and education. And what we build off is what we call the 5 Cs. So we build connectivity, and that's fundamental. But on top of that, we provide continuity. We provide an environment that is not tied to a single funding stream. We're independent. We're basically not reliant on a project or a grant from somebody. And we've been able to do this for over 25 years now because we are member-funded, member-led. We provide an environment for coordination, so where we can bring together co-location of equipment, meeting points for exchange points, and so on, where there can be shared investment. The bilateral links between two countries quite often have a maybe 50-50 or maybe a 10-90 share of the costs of such a link. And in some cases, it is just an external funding grant that provides 100% of the cost of the link. One of the strong points we have in the APAN community is what we call the Common Acceptable Use Policy, which basically means that if you partner into APAN and you bring a link, then you agree to make that link available to other APAN participants. So if we get a link from Europe or the US, we come to a meeting point in one of the APAN hub sites, that link then becomes available to all of the economies that connect into the APAN framework. And the acceptable use policy basically is focused on research and education, non-profit activities. So in theory, we can have industry partners connect as well for the purposes of supporting research and education. We support a lot of collaboration by providing shared platforms. So for example, during our pandemic mode virtual meetings, we provide Hoover and Zoom licenses and access to a whole range of platforms. We identify services that some NRENs can offer, that can offer it more broadly. We can provide information and contact points and so on. And basically what we're getting is this economy of scale of aggregating all this information in one place. And the fundamental thing is that APAN is about its community. One of the key things that APAN did when it formed was to focus on the actual end users to start with. So the first working group in APAN was in fact agriculture and biosciences, or bioinformatics as it was called. That was set up at the same time as we were setting up technical working groups around IPv6 and multicast. And what it meant was that we had a really good relationship with those research communities very early on, who identified the needs of where they needed to connect to, where did they need capacity to. a lot of the time, if you go to the government and say, hey, we would like some money to build a link between my country and your country, they say why, which is quite a reasonable question. In APAN's case, we have that information, that knowledge up front from the communities that will use the links. So we can say to them, well, we've got 5,000 agricultural researchers and bioinformaticians who want to connect with their peers in that other country. There's going to be a huge amount of demand that, as soon as a link is built, it'll become quite busy. And that becomes a very convincing argument, which is much better than, say, some places where you get, let's say, a supercomputer or a new network link built because it seems like the right thing to do, but there's no user community, no demand demonstrated yet. So there's a risk for the funding bodies. And so we can demonstrate that demand up front. And we've done that over and over and over again. And that has been proven really effective, as that network map shows earlier on. The community that APAN supports is broadly classified into what we call the application and the technology areas. And the application area has evolved massively over the years, as has the technology. As I said, agriculture was the first working group in APAN, and it is still going. It is still very, very active. We've had other working groups come and go. Earth systems and remote sensing is now just so widespread. It's an off-the-shelf platform almost for most things, but access to some of the newer data sets are being coordinated. We have an e-culture working group about capturing the culture and arts and history of many economies and sharing that in real time across the networks. High energy physics, the physical sciences, medicine. The telemedicine working group is one of the biggest working groups in APAN. And if you look at the program, you'll see a medicine session every day in every single slot. They have so much content, so much discussion going on. And in fact, they now run their own workshops between APAN meetings as well. We have a new working group, well, it's a few years old now, in disaster management, dealing with natural disasters, health and medical disasters, and so on, looking at what kinds of technologies are available that can help, can provide information, provide access, even down to working out how to provide network connectivity. And then, of course, in the technology areas, excuse me, we have working groups in a whole range of emerging technologies, some of which come and go over time, some of which come back. And we basically try and bring all of these communities, all of these working groups together around our two major meetings that we have each year. In a normal face-to-face meeting, we have 300 to 400 people typically attend. During the virtual meetings, we've had well over 1,000. The benefits of having remote access, of course, proven well and truly. The meetings are basically roughly every 6 months, usually January, February, March, and then August, September for the other half of the year. We're now starting off APAN 54. So this is literally our 54th meeting. The next meeting will be in March next year in Nepal. And then APAN 56 is yet to be determined. That'll be this time 12 months from now. And hopefully we'll work that out very quickly. And APAN, the community of participants in the various working groups and so on, they're not just focused on the Asia Pacific community, they collaborate globally on all sorts of infrastructure and discipline areas. And you'll hear talk about what we call the e-research infrastructure or the e-science infrastructure, or what the US calls cyber infrastructure. It's about the IT that enhances and enables research to occur, the ability to bring together data from newer data places, more data sets from different areas, bring it together, aggregate it, fuse it, analyze it, share it, and collaborate around it. And that requires a whole bunch of things to work really, really well. We need the computers, we need the data storage, we need the collaboration tools. Some of them are discipline specific, some of them are very generic. We need the networking, we need that connectivity, and it needs to be wide, it needs to reach across many different institutions, and it needs to go deep. It needs to be able to reach sites in remote areas. The telemedicine working group does training for hospitals in the middle of the Himalayas in Nepal. That is a challenging area to run a high-speed fiber to, but they are able to use other technologies to get in there. And one key area that's becoming more and more important these days is around security and trust. The ability to identify people, to give them the ability to authenticate into applications, to say, I give permission to this class of users or this group of users to access my computers, my data, my networks, and so on. That is not easy to do on a global scale, but there is an identity and access management working group that shows you how these national and international federations are now able to do that. And you can use your university logon from your home institution to connect to a computer on the other side of the planet. And you can use the same password and username on that. The working groups that we have, they have active discussions at each APAN meeting, and there are some fascinating activities that are going on. Agriculture has moved from not just sharing information about how to improve agriculture, but to increasingly these effectively sensor network-based systems. At one stage, we used to have remote sensing, and you'd have stuff on the scale of 1 kilometer wide. Nowadays, we're able to build sensors that you can have 1 per farm, 1 per paddock, 1 per row, 1 per plant, where you can have temperature and humidity and soil characteristic sensors scattered across a farm with very high resolution. They auto-build mesh networks, and the data gets aggregated into a central point, and then the farmer can analyze that data, or it can be shared centrally. So, agriculture has changed immensely over the last 20 to 30 years. Disaster management working group does a lot of stuff with remote sensing, but also with collaboration tools. So top left picture, I think, is from one of the typhoon strikes that the Philippines endured a few years ago. And they were able to get satellite data within a matter of hours to show the extent of the damage, where help was needed, and so on. The top right image shows smoke plumes from land clearing and also from natural fires, where the smoke basically builds up, depending on weather systems, across a particular area. So, Singapore and southern Malaysia were heavily impacted at one stage by fires that were occurring in parts of Indonesia. You get similar things occurring in across China, eastern parts of China, and so on, with dust storms and so on. Bottom right shows a platform for video conferencing that was established to support one of the pandemic outbreaks about 10 years ago, where hospitals in some of the economies had to lock down. And that meant that doctors were either locked in or locked out and separated from their patients, or tied in and could not get access to other experts. And so some of the APAN engineers worked together on building a platform that could use off-the-shelf products, and then basically give them access to allow the hospitals and the staff there to have access to specialists, and for people to have access to their families. And Dumbo in the bottom left is basically a mesh wireless networking platform that can be brought in where a disaster has occurred, and you suddenly don't have electricity, or you lose cable connectivity, or towers are blown over or burnt down because of a fire or a storm or an earthquake. And so, having connectivity and information sharing during a disaster is one of the best ways to help start the recovery process. Remote sensing, we've had a lot of interesting data sets that we've looked at over the years. We partnered with NOAA in the US for many years, and they had some of the most amazing data sets. You could look at the boats in the oceans doing squid fishing and so on, because they use these huge lights. You can see the lights at night. You can see where the fishing fleets are moving around. And that can then be tied to other data sets that talk about fish populations, octopus populations, and so on. There's some really interesting LiDAR data that's available. These are aircraft flying across an area. You can see the flight paths there are quite complex. And what they're basically doing is sending a pulse laser down to the ground and measuring the reflectance time, so effectively the altitude. And that means they can look underneath the tree cover, because they'll get reflections off the trees, but you'll also see the reflections directly off the ground. And they can measure heights and altitude changes on accuracy of millimeters, which is really useful for monitoring things like volcanoes, earthquakes, and so on, because the ground will shift in very subtle ways. That's hard to do when you're just trying to walk through a jungle and so on. A bottom right image shows a very bright yellow dust cloud over China. That is a massive dust storm blowing across central China into eastern China, and then will probably blow across the bay into Korea, maybe even across as far as Japan. And so seeing this coming allows you the chance to respond to that. Another area of APAN supports collaboration, education, training, e-culture, so the sharing of cultural heritage and knowledge. So we've had things like virtual concerts, virtual dance performances with multiple locations involved. That tests out the technology, but also allows us to capture unique cultural performances from individual economies. And so there's a lot of training and testing that goes on around those activities. And normally when we have face-to-face meetings, we try and arrange demonstrations of this, because it's quite impressive. That performance on the left-hand side, in fact, has the violinist and harpsichordist, I think, in Europe. The cellist is in South America, and the dancer, who's just barely visible behind the letter D there, she's in Thailand. But they're all performing together. And yes, there are some really interesting challenges around the latency of this audio and video transmission. We do support activities around the Internet of Things, sensor networks, and so on. As I mentioned, you can now get individual sensors down to the plant level. The devices that were down to the size of, a matchbox or the size of your thumb are now down to the size of a thumbnail and smaller. I have seen sensors that are down to almost the size of dust, that are scattered around. They're solar powered or radio powered, and they build an ad hoc mesh network. The Sense-T project in the top right was effectively an attempt, and it's still going, for an economy-wide sensor network. So it's bringing together not just farm sensors, but also government sensors, transport sensors, people movement information, and so on, meteorological data from larger scale systems. And they were used in things like discovering why there was a major pollution flow into an oyster farm. And they discovered that it was a combination of a farm having issues with some road construction works that led to runoff occurring in a completely unexpected way. And nobody had ever seen this before and wouldn't have had a clue how to work out how this was happening until they started building sensors everywhere and getting this data aggregated into the middle and sharing this data. We also do, well, a little bit of a warning, I have medical images next. The telemedicine working group does a lot of training for doctors around the world now. And so they will demonstrate surgeries in real time. They will demonstrate, and we have seen demonstrations of telerobotics, where a doctor in one country is driving a robot in another country. Obviously, you want a very reliable network in that case. And basically, this provides access to specialist expertise all around the world. Your location no longer matters if you have a good network. And so you can get training from some of the leading experts in the world. Kyushu University leads the telemedicine working group, and TEMDEC, which I forget the exact acronym, but it's basically a telemedicine center of expertise that is now a global partnership that is effectively spun out of the APAN working group. And the same people are involved in both of those things. And as I said, they completely fill the program with really good content. But feel free to go to their sessions. Just be aware that occasionally you will see some slightly medical images. And we also support more strategic things. So things that involve, for example, major water flow systems. We did some big workshops with UNESCO around the Mekong Delta. We've done some other partnerships around dengue fever management, its detection, its management, and so on. And the latest research on mitigation techniques. And that can bring together many government agencies into a single room at one time to talk about the technical aspects of sharing information, but also the clinical, the medical, hydrological, because obviously dengue is mosquito-based, understanding where water is flowing or not flowing, causing issues and so on. All of that information can be aggregated and used to help combat that. Now, the Apan structure is fairly simple. We have a governance structure, but most of our activities are around our working groups. We have the application technology area. And as I keep saying to people, if you want to set up a working group, just go ahead. There's a process, a fairly simple one to go through. What you just need is a group of people interested in using the networks to enable something, to bring together people around a common interest, and somebody needs to be a chair of the working group. And you don't have to be a member of APAN or a member economy of APAN. You don't need to be a senior academic. A student can start a working group if they wanted to, or somebody from industry for that matter. The working groups are basically long-lived entities. As I said, agriculture has been around for over 25 years now. We also have task forces, so they're basically more project-oriented. And again, if there's a particular need, a problem we need to solve, and so on, something to put together, we can set up a task force quite easily. We have some management committees. We have a program and event committee. Excuse me. We have a election backbone committees, network operations center, and our fellowship committee. So normally in a face-to-face meeting, APAN will subsidize through a fellowship program people to come from mostly developing economies to attend an APAN meeting in person. Excuse me. Spring is coming into Australia. My hay fever is starting to kick in. All right. The oversight of APAN is through its council of members. So basically, it's all the members who set the strategic direction for APAN. They meet once every 6 months, usually at or just after an APAN meeting. And then we have a board of directors who provide the executive management. They are a subset of usually of the council of members. They are legally the directors of APAN for the purposes of the Hong Kong regulators. And our chair is Professor Jinan Wang from CERNET in China currently. Everybody is a volunteer in APAN. So our budget is very, very small. The only people who get paid, and obviously never get paid enough for all the hard work they do, are the APAN Secretariat in particular, who are currently based in Malaysia. So you will see Liana and Sean appearing from time to time in various places and in your emails. And as I mentioned, I'm the general manager part-time based in Australia. The meetings that we have, or conferences that we run, basically have a range of different sessions. We have very, very flexible programming arrangements. Basically, if people have a good argument for a session, we can set up a session as long as there's enough room. So the working group sessions are the most common ones. We have some committee sessions. We have our plenary keynote sessions as well. During this virtual environment, we're having one each day. We have the General Assembly at the end of the week, which I chair, which is basically a summary of the whole week's activities. So all of the session chairs present there, the committees present there, very, very briefly. Everybody gets about 2 minutes each, so it's very, very quick. But it just gives you a sense of just how rich the program is across the whole week, because you can't get to everything when you have 5 or 6 parallel streams. Even in Zoom, you can't really watch 5 streams in parallel easily. Usually we have social events during APAN meetings. We run a number of workshops and tutorials. A lot of the groups that partner with APAN provide training around services. So groups such as APNIC, the NSRC, Startup, the Network Resources Startup Center out of Oregon. They do a lot of training, workforce development, and so on. So they use the APAN meetings as an opportunity there. Certainly in face-to-face meetings, you'll notice there are a lot of side meetings going on where people suddenly go, oh, let's get a group together to talk about this. And so you'll quite often see the corridors full of various meetings, and we have lots and lots of side meeting rooms as well. And then we have the council meeting, which is usually held somewhere during the week or shortly afterwards. And then the thing with all of these sessions is that all of them are open. You can go to any of those meetings if you want to. Council might be a little bit restrained, but the other meetings are generally open to everybody. And so if you have an interest in a particular working group, you don't have to be a member of a working group. Being a member of a working group basically means you get added to the mailing list and not much else. So if you're interested in a topic, you can walk into any session you like. And in the virtual world, feel free. It's easy to do. Okay, I'm going to end there, having now blasted your ears for half an hour, and open it up to any questions. Let me stop sharing. Feel free to turn your video on or not. Feel free to talk or not, or put a question in the chat. Happy to take questions. Normally in the APAN introductory sessions, we also have a brief discussion time with the APAN fellows as well, most of whom are new to APAN. So normally in a face-to-face, it's a little bit longer, a bit more interactive. Okay, if I don't see any questions coming, we can close the session and I can free you up to go to other sessions. No hands going up, nothing in the chat. In the auction world, I'd say going once, going twice. Thank you, Jennifer, appreciate that. I will release you all. We will stop the recording and end the session.